S. Chan presents Educational Video Lectures. Difficult concepts made easy. Study anywhere, anytime.
Welcome to S. Chand Academy, and I am Anmol Bhatia. In this part of the video, we will be learning about an important principle, which is D'Alembert's principle. D'Alembert's principle is basically used to convert a body which is there in the dynamic equilibrium into the static equilibrium. So let us understand D'Alembert's principle with the help of statement and with the help of elaboratory examples.
If you want to study this topic in detail, refer to the book by S. Chan Publishing. Link is provided in the description box.
The topic is D'Alembert's principle. It is a part of the course Engineering Mechanics. And this D'Alembert's principle states that whenever there is a moving body and that body is having a dynamic equilibrium, if that body is required to be brought to the static equilibrium, how can we achieve this conversion? By doing one particular thing, which is by applying an imaginary inertia force. So we have to apply an imaginary inertia force which is of the same magnitude, but that force is accelerating in the opposite direction. Now what does this statement particularly mean? Let us understand this particular statement with the help of one diagram. So in this diagrammatic presentation, what do you have? You have an object which is having this mass m, and that is accelerating with the help of force having this acceleration a, and this body is there in the dynamic equilibrium. So as per the Newton's second law, what do you have? F equals to ma. So if I subtract this ma, or if I take this ma on the other side, I will get 0. That means it would be converted into the static equilibrium. Now what is being done here, I have this particular force which is accelerating force, which is F equals to ma, and what I have to do, I have to apply another imaginary inertia force, which is another imaginary inertia force having the same magnitude. So the force was F equals to ma, it is having the same magnitude F equals to ma, but that force is accelerating in the opposite direction. So it would have a minus sign. So this acceleration remains the same. So ma minus ma would be 0. That means the object would be there in the static equilibrium now. So we want to convert this object which is in motion and having a dynamic equilibrium, and if it is required to be converted into the static equilibrium, what has to be done? We have applied a force of the same magnitude, which is the same force, but it has an opposite sign. So minus ma part is to be added in this particular set. Now we will learn this concept with the help of one numerical problem. So the numerical problem here states that there are two bodies A and B. So you have two bodies A and B, and they are connected by a thread. It is connected by a thread, and that body moves on a rough plane, and that rough plane has a coefficient of friction as 0.3. This coefficient of friction is 0.3, and this plane is mentioned to us, and that plane is a rough plane, and there must be certain tensions involved. So this is given to us. You need to find out the acceleration of the two bodies, and the tension in the thread using D'Alembert's principle. So tension is there in the thread, and the two bodies would have the acceleration part. We need to apply D'Alembert's principle to find out the acceleration and the tension. How it can be done? First and foremost, we consider this A object. So the A object is having a force which is this force, which is 200 Newton, and to balance it up we have another reaction force which is Ra. So the tension that is there in the thread is T, and applying the D'Lambert's principle, we have to give the force which is equal and opposite. So, ma is to be given into the opposite direction. Additionally, this floor, which was the rough surface which is having the coefficient of friction 0.3, that is to be considered. So, 0.3 multiplied by Ra would be the another force which is being offered, another resistance which is being offered by the floor. So, we know that F equals to mg. So, from there we have to find out what is the mass for this particular force. So, mass is 200 divided by g, which would be the mass 200 by 9.81, and you are seeing that there are two particular cases. One is the x direction force, another is the y direction force. So, the x direction force and the y direction force, or both the two forces, are to be considered equals to 0. So, first and foremost we can consider this y direction force, which is 200 and Ra. So, Ra minus 200 would be equals to 0 because they are in the opposite directions. From there Ra can be determined easily, which is 200 Newton. Then considering the x direction forces, so T is one of the force, Ma is one of the force, 0.3 Ra is another force. So, summation of all the forces in the x direction, that would be equals to 0. So, T minus 0.3 Ra minus Ma equals to 0. So, on solving you will get this value of T as this one, which is in terms of acceleration. So, this is as far as the A object is concerned. Now, considering the B object, and we have to go with the D'Lambert's principle again. So, this B object indicates that it is having a force of 800. So, the force of 800 is applied and the opposite reaction is Rb. Herein this 400 Newton is one of the force which is being given on the x direction, and the counterbalance force is this T, which is this tension, which is this one, counterbalance force. Additionally, the force which is being offered by the floor is 0.3 times Rb. So, 0.3 times Rb is the force which is being offered by the floor, and you have this 800 value of the force. So, from general formula, which is F equals to mg, F is 800 and mass is required, g is 9.81. So, 800 divided by 9.81, which is the value of mass for the B body. So, this mass multiplied by the acceleration will be the opposite force which is being offered by the body B. Herein you have two particular forces of in y direction, and you have number of forces in x direction. So, we need to balance the forces together so that equation comes into the picture. So, Rb minus 800, which is the summation of all the forces in y direction. So, from there Rb comes out to be 800 Newtons. Additionally, sum of all the forces in x direction is equal to 0. So, 400 minus T minus 0.3 times Rb minus this force, which is this on the other side, that is equal to 0. So, from there you got an equation of T again, which is the tension. So, tension is common if it is applied by A or if it is applied by B, as stated in this example with the help of the diagram. So, what you need to do, you need to equate both the values of tensions. So, tension value that was obtained from the first is this, and the tension value which is obtained from the second case is this. You need to equate both of them so that acceleration comes out. So, on solving both the two equations, acceleration's value is 0.981 meter per second square. So, what was required? You need to find out you were required to find out the acceleration of the two bodies. So, acceleration you got. Now, what additionally is required? Tension. So, what you can do, you got this equation number 1. So, what you can do, you can substitute the value of acceleration in any of the two equations, so as the value of T can be determined. So, acceleration value is 0.981, that can be substituted here so that the value of tension comes out. So, tension is 80 Newtons. so you can solve it easily. So this is one of the case of the rigid bodies in which you are given with this body placed on the floor and it is connected to another body, and we are moving, or we are pulling the two with the help of the force of 400 Newton. So what we have done, we have applied D'Alembert's principle in it so that the value of tension and acceleration can be determined. So we stop here for a short break. After coming back from the break, we will learn the concept of D'Alembert's principle more into the detail.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy. After the break, before going to the break, we have learned what is D'Alembert's principle with the help of a particular set of diagram. Additionally, we have seen that D'Alembert's principle with the help of a numerical. Now, in this part of the video, we will be learning the D'Alembert's principle with the help of more examples. So straight away, I am coming to the example in which it is mentioned that you are having two weights, and those two weights are P and Q, and they are connected by the arrangements as shown in the figure. So you have the pulley arrangement. You have this first particular pulley, and that you have the second pulley, and the two weights are tied on it. So one is this P, another is this Q. So there are two which is being tied. Now what is required? Neglecting the friction and the inertia of the pulley and the cord. So you don't have this friction involved in the pulley and the cord, and what is required? You need to find out the acceleration of the weight Q. So the acceleration of this weight Q is required, assuming that P is 178 and Q is 133.5. So values are mentioned to you of P and Q, and acceleration is required. So D'Alembert's principle is to be applied. So in order to apply that D'Alembert's principle, what you have to do, you have to break the two into the two segregations. One particularly was P. So the P part was having this value of load, which is 178, that would be acted in the downward direction, and you have this 2T part. So the double tension would be there because it is connected to another pulley. So the double tension would be there, which is 2T, and because it is connected to two pulleys, so acceleration would become half. So acceleration is A by 2, and here this force was 178. So F equals to MA, mg. F is 178, mass is to be required, and G is 9.81. So from there, M is 178 over 9.81 multiplied by the acceleration value, that is to be taken into consideration. Now what we have to do, we have to equate or sum all the forces which are acting in the y direction, and we need to put it equals to 0. So 2T will be one of the force which is acting in this direction, and the opposite direction forces are to be subtracted, and we need to put it equals to 0. So 178 and this particular equation, both of them are equated, so that you obtain one particular equation, and x direction forces are not there because it is being joined with the help of that pulley and the rope arrangements. Additionally, if I look at the Q part, so Q was connected, as per the diagram, Q was connected to one pulley only. So the acceleration would be this A part in this particular case. So what you have to do, you have to consider this Q, which is having this tension, which is single tension T, and having a load of 133.5. Additionally, this 133.5 would have a counterbalance which is MA. So 133.5, that would be equals to mg. So 133.5 divided by this acceleration due to gravity, which is 9.81, that would come out to be the mass, and that mass multiplied by the acceleration value. Here the acceleration value is a, so it would come out to be mass multiplied by the acceleration only. So on summing all the forces, which is y direction forces, we need to put it equals to 0. So what do we get? This tension, which is T, and this part, which is 133.5 in the negative direction, and this part is there in the direction of T. So plus 133.5 divided by 9.81 into acceleration, so m into acceleration. So from here you can find out the value of tension. So this is the second equation that is required to be obtained. Now both of them are the values of tension. So what you need to do, you need to mention that you have obtained these two values, which is this value from the first part and this value from the second Q part. This T can be substituted here in this equation, so you can substitute it here, so that one equation comes out, and on solving, acceleration's value is 2.452. That is what was required in the question, that the acceleration of the weight Q was required, and if the acceleration of the weight P was required, so for that you have to divide it by 2. Now the second question, which is related to the concept of rigid bodies, we have to look. The second question states that you have a horizontal bar. This is the second question. And now it says that you have a horizontal bar which is of length 1.5 meter. It rotates about the vertical axis through one end. So you have the vertical or horizontal bar, and that horizontal bar is rotating around about this vertical axis through one end, and it rotates at 1200 rpm, another at 1500 rpm. We have two sets of rpms, 1200 rpm and 1500 rpm, and it rotates for a particular value, which is 5 seconds. What is required? You need to find out the linear velocity at the beginning and the end of the interval. So velocities are required. Those velocities can be determined from the RPMs mentioned. Additionally, normal and tangential components of the accelerations of the midpoint of the bar is required after 5 seconds when the acceleration begins. So we look at the question. So first and foremost, we have to convert this particular question into symbolic representations. So 1200 rpm is N1 and 1500 rpm is N2, and the time period, which is 5 seconds, that is 5, which is T, and you have to find out the angular velocities. So angular velocities is having a formula which is 2 pi n by 60. So for angular velocity 1, you have to use 2 pi n1 by 60. So n1 value is 1200, so you can substitute 1200 here. So 2 pi into 1200 divided by 60, you will get this omega 1 value, which is 40 pi radian per second. Then secondly, you have this value of n2, which is 1500 rpm. So in the same formula, using this w omega 2, which is 2 pi n2 by 60, you can substitute n2 as 1500. So after substituting n2 as 1500, you will get the value of omega 2, which is 50 pi. So you got two values of the angular velocities. Now what was required in the question? You were required to find out the linear velocity. So the linear velocity and angular velocity is having this relationship v equals to r omega. So r omega 1. So it is mentioned that the length is 1.5 meter. So this 1.5 meter length was there of the horizontal bar, and it rotates about the vertical axis. So if this horizontal bar rotates about the vertical axis, that means it forms a circle with the particular radius, which is 1.5. So radius 1.5 is to be substituted here, and 40 pi is to be multiplied, so that V1 value comes out to be 188.4. So from here you can find out the value of V1. Similarly, V2 can be obtained. V2 is 235.5 meter per second. So this first part is complete, which indicates that linear velocity is to be determined at the beginning and the end of the interval. So beginning and at the end of the interval is connected with the initial RPM and the final RPM of the body. Now, what is required? Additionally, you want the normal and the tangential components of the acceleration. So for finding out the normal and the tangential components of the acceleration, first and foremost is to find out what is acceleration. So in terms of this angular velocities, you have this representation, which is omega 2, that is equal to omega 1 plus alpha t. So what is this equation and where does it come from? V equals to u plus at was the initial equation, and we have replaced this V equation with the help of this angular velocities and angular accelerations. So we obtained this omega 2, we obtained the omega 1 value, and we obtained the value of time period. So time period was 5 seconds. So on substituting all these values, you will get the value of acceleration, which is 6.28 radians per second on substituting these values. Now, it was mentioned that you need to find out the tangential and normal acceleration component of the midpoint of the bar. So you have this particular horizontal length, which is there, horizontal bar of 1.5 meter that rotates about this vertical axis. Now what was required? You need to find out the middle value. You have to find out the tangential forces and the normal forces at the middle section, at the center. So for that you need to consider the distance as half, because it is mentioned in the question. So the tangential component, which is acceleration t, that would be r multiplied by alpha. R here is half the length multiplied by alpha. So length was 1.5 divided by 2, because it is mentioned half, and acceleration we have calculated, which is 6.28. So on solving you will get this acceleration value, which is again in radians per second square. This would be the value of the tangential component of the acceleration. And for the normal component of the acceleration, you have to use this formula, which is r omega 2 square. So r is mentioned to you as L by 2 and omega 2 is 50 pi. So put in 50 pi whole square. So on solving you will get the value of the normal component of acceleration. So one which was required, the tangential component, and the second is the normal component of the acceleration. So summarizing this particular question, it is basically an application based set of question in which let's say a fan is rotating and you have certain horizontal component which is fixed to the fan, and you need to find out what is the value of accelerations on that particular component which is there placed in the horizontal direction. So you can use these particular set of equations which is related to angular velocities and angular accelerations, so that this normal and tangential components can be calculated. So with this we come to the end of the video, in which we learnt D'Alembert's principle with the help of certain examples. Additionally, we have seen a numerical in which we have determined normal component and tangential component of the acceleration in case of RPMs and angular velocities. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.